Hi students, welcome to SSJA Chemistry. If you are preparing for mains, AIIMS and NEET, this channel is very helpful and I will give assurance for mains, AIIMS and NEET. If you follow each and every video, I will give assurance for mains, AIIMS and NEET. Okay? And today topic is coordinate covalent bond. One of the most important topic, and definitely if you don't skip the till end, you will definitely understood what is coordinate covalent bond is. Okay, coming to the topic, coordinate covalent bond. Coordinate covalent bond, it is also a special type of covalent bond in which electrons are shared between electron rich compound and electron deficient compound. Electrons are shared between electron rich compound and electron deficient compound. This is what we call coordinate covalent bond. Electron rich compound to electrons are shared between electron rich compound and electron deficient compound. Electron deficient compound. Okay, rich compound and electron deficient. Next, it is indicated by an arrow mark. It is indicated by an arrow mark. Coordinate covalent bond is indicated by an arrow mark. We can observe here. It is indicated by an arrow mark. Next point, it is also called as coordinate covalent bond is also called as a day-2 bond. Okay, these three points are important. Now we will go with the examples. For example, NH, electron rich compound and electron deficient. Electrons are sharing between electron deficient compound and electron rich compound. Okay. First of all, understood what is electron deficient compound. What is electron deficient compound? Electron deficient compound. Okay. Electron deficient compound. Electron deficient compound means here, for example, BF3. Here, boron is the central atom. Electronic configuration 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. 2s2, 2p1. This is the electronic ground state electronic configuration. Ground state electronic configuration. Ground state electronic configuration. Okay. Electron jumps from 2s orbital to 2p orbital. Then excited state electronic configuration is excited electronic configuration is 2s1, 2p2. This is the excited state electronic configuration. Now each electron is interacted with the fluorine. Each electron is interacted with the fluorine and forming BF3 molecule. The boron excited electrons are interacted with the fluorine. Each electron is interacted with the fluorine and forming BF3 molecule. So now this is the BF3 molecule and it has how many electrons are there? 6 electrons. There are 3 electrons in the orbits and these are the 3 electrons. Okay, total 6 electrons. According to Oxidation rule, 8 electrons should be there in the outermost orbital for to get more stable. But here it is a 6 electrons. Okay, so it is a short of 2 electrons. Normally 8 electrons requires for to get more stable. But here 6 electrons are there. How many electrons left? 2 electrons. 2 electrons it requires. Okay, so it is a short of 2 electrons. So this is called the electron deficient compound. It is a short of 2 electrons. So it is called as electron deficient compound. Okay, electron deficient compound. Another example, AlCl3. AlCl3. Al, aluminium. Electronic configuration. See here. Aluminium is atomic number 13. 1s2, 2s2, 2p6, 2 plus 2, 4, 4 plus 6, 10, 3s2, 3p1. This is the ground state electronic configuration of aluminium. Next, excited state electronic configuration. Outermost 3s2, 3p1 is there. 3s2, 3p1 is there. Outermost electron. Next, excited state electronic configuration. So electron jumps from here to here. So this is also like this. Okay, excited state electronic configuration of aluminium is like this. Here each electron interacted with the chlorine. So each electron interacted with the chlorine and forming AlCl3 molecule. Here you can observe how many electrons are there? 6 electrons are there. 6 electrons. But how many electrons requires? How many electrons should be there? According to Oxidation rule, 8 electrons should be there. But here 6 electrons only there. So it is a short of 2 electrons. So 2 electrons it requires. So AlCl3 is there. It is a short of 2 electrons, so it is an electron deficient compound. BF3 is also a short of, it is a short of 2 electrons, it is also called as an electron deficient compound. Okay, electron deficient compound. Understood what is electron deficient compound? And what is an electron rich compound means? Electron rich compound means, actually easily you can understand what is electron rich compound means. If any lone pair is there, and not only lone pair and negative charge is there, then it's also, it ready to donate electrons. Okay, if you consider NH3, then in NH3 nitrogen atom has one lone pair. And this lone pair is ready to share. If it is ready to share and forming bond with the electron deficient compound, then it is forming coordinate covalent bond. See here. And NH3 has lone pair, which is indicating that it is a electron rich compound. Lone pair, if it is lone pair or negative charge, okay, is there, then it is an electron rich compound. And it is donated to where? It is a BF3 molecule. BF3 is an electron deficient compound. This lone pair is donating to electron deficient compound. And forming bond. Which bond it is? Electron rich to electron deficient bond, sharing. So it is an electron. This is the coordinate covalent bond. It is indicated by an arrow mark. Okay. Here the lone pair is shared between nitrogen and boron. This is coordinate covalent bond. Next, one more example. Here NH4Cl. In NH4Cl, NH4 plus Cl minus. Ions are formed. The attraction between the ions is called ionic bond. And in NH4 plus means NH3H plus. NH4 plus means NH3 plus H plus gives rise to NH4 plus. NH3 plus H plus gives rise to NH4 plus. Here NH4 plus, here it is what it is forming. NH3 is an electron rich compound. It is H plus is an electron deficient compound. So it forming a coordinate covalent bond, sharing of electrons between electron rich compound and electron deficient compound. So it is electron. What it is? It is a coordinate covalent bond. Okay, coordinate covalent bond. Next, in NH3, N forms hydrogens. In NH3, sharing of electrons takes place here. These bonds are due to sharing of electrons. So sharing of electrons means covalent bond. So in NH4Cl you can observe both ionic bond, covalent bond and coordinate covalent bond. Okay, this is what. Next, one more example. Okay, next NaBH4. NaBH4 is an example. NaBH4. If you consider the NaBH4, in NaBH4, how it is divided? Na plus BH4 minus. Na plus and BH4 minus. So there is an attraction between the positive charge and negative charge. So it is called an ionic bond. Attraction between the positive charge and negative charge. So it is an ionic bond. Next, BH4 minus. BH4 minus, actually BH3 plus BH plus. Okay, BH3 plus H minus gives rise to BH4 minus. Here BH3 is an electron deficient compound. And H minus is an electron rich compound. Sharing of electrons between electron rich compound and electron deficient compound and forming BH4 minus. It is an electron. This bond is called coordinate covalent bond. coordinate covalent bond. Okay. Next, in BH4 minus BH3 plus BH and formation of BH4 minus from BH3 and H minus is coordinate covalent bond. Now coming to BH3, BH3 is formed due to sharing of electrons. So sharing of electrons because and then it is covalent bond. So in NaBH4 we are observing ionic bond as well as coordinate covalent bond as well as covalent bond. Okay, understood what is the coordinate covalent bond and what is the difference between ionic bond and covalent bond? Okay, thank you. If you understood this video, if you like this video, please share and subscribe and comment.